This example will essentially deal with rotational dynamics of our rotating object. Let's suppose that a 30 Newton force is acting on a massless cord that is wrapped around a disc that has a mass of 10 kilograms and a radius of 55 centimeters. Now, our disc accelerates at a constant rate for 3 seconds until it reaches an angular velocity of 45 radians per second. Now, if there exists a frictional force inside our disc that opposes our rotation and creates a frictional torque of 3 newtons times meter, we want to calculate what the moment of inertia of our rotating object is. So we want to calculate the rotational inertia. So let's examine our diagram. So here we have the radius, which is 0.55 meters. We have the frictional force that opposes the motion that creates a torque of 3.0 newtons times meter, and we have a tension in the cord that is equal to 30 newtons that opposes this frictional force. So they point in different directions. They create torques that point in different direction. So this torque points counterclockwise and is positive, and the torque created by the frictional force points in the clockwise direction and is negative. So we're essentially going to use this formula, which is the equivalent formula of Newton's second law of motion for rotational motion. And we're going to use it to solve for our I, which is our moment of inertia, also known as rotational inertia. So we want to calculate what the net torque on our object is, then we calculate what our angular acceleration is, and then we solve for our I, our moment of inertia. So let's begin by taking the sum of the torques. So in this example we have two torques. We have the torque that is due to this tension force, and we have the torque due to the frictional force. So we choose this force or this torque to be positive. So torque tension is positive minus our torque due to friction. So notice the torque due to tension is simply this force which acts at an angle perpendicular to the radius multiplied by the radius, which is also our lever arm. And this torque friction is given. So that means we have 30 newtons multiplied by 0.55 meters minus 3 newtons times meter, so 16.5 minus 3, which is 13.5. So this is our net torque. So now we want to find the instantaneous acceleration. Now because our acceleration, our angular acceleration is constant, that means that instantaneous acceleration is equal to the average acceleration, which is equal to the change in our angular velocity divided by the change in our time. So our final angular velocity minus initial angular velocity divided by change in time, our final angular velocity is given to be 45 radians per second. The initial is set to be 0. So we simply have 45 radians per second divided by a time interval of 3 seconds, and we get 15 radians per second squared is our instantaneous or average angular acceleration. So now we simply rearrange this equation and solve for our I, our moment of inertia. So the moment of inertia is equal to the net torque acting on the object divided by the angular acceleration. So we have 13.5 newtons times meter divided by 15 radians per second squared, and we get 0.9 kilograms times meter squared. So this value is the moment of inertia of the object, also known as the rotational inertia of the object.